Okay, so a few things we learned today, which is pretty awesome. So this is the amalgamation of all, or like a summary of ferments, the major categories, which are covered in another video, and also set up for some of those to maximize CFU and strain diversity and to maximize success. So balancing those two out. And you can see here how you read this is set up. So for weights, what is the best to weigh stuff down? So perfect fit ceramics, so that's like a ceramic bowl that can be pressed down by the lid. So you put it at top, and then when you screw it on, it presses down and it fits perfectly. Apparently, given the standards, that happens a lot. Number two is the glass. Glass weights don't always fit around. It's not perfect, it's not fit. Sometimes it's a little bit harder to get it out, and with ceramic, you can just kind of scoop it out like from inside. With the glass weight, you can. Usually they have handles, but again, this is why it's pretty good. And then anaerobic lids, you have the water-moat, so what they use like in China or Japan for the miso jars. And then it's a 3-piece airlock with grommet, so that's the part on top. Like, it looks like water that you have to pour into like a plastic container of water, and that's going to be your water-moat 3-piece airlock with grommet, the silicone kind of more like stopper on the lid with a hole in it. They come with sets. Jimlo's one. 2 is a non-silicone wired release valve. That is because the silicone, usually, at least from meta-analysis, like 2 videos put it at the bottom because failure rates were really high. But non-silicone, kind of like the plastic seal lids. And then the 3rd is just use a standard lid and burp it every now and then. And you have aerobic lids, 1 flour sackcloth. So fold it 4 times to keep flies out, or you can do really thick cloth towels. And then using a natural rubber band. These are the dimensions to fit on the mason jar, 32 ounce wide mouth. Looking at these, again, it's 1/16 for milk plant kefir. So you're gonna do, I can edit this, and a lot of these are kind of ratios for a given amount, so they're all standardized. So for instance, this would be a cup. You can see 1/2 cup RO water, 1/2 cup hemp, blanched almond or pistachio. Those are the best nuts given the protein. We covered that in another video. And then you're going to want this 1/16 teaspoon of Celtic salt, so Celtic sea salt, and then 1/4 a teaspoon of blackstrap molasses. So those give kind of minerals and other nutrients. And then here you have the actual, you want 5 grams of milk kefir grains, or 1 teaspoon. And again, that's usually this is all for 1 cup. And this is plant-based kefir, so with actual kefir, you're probably going to want 3 to 4 grams of milk kefir grains, a little less. Anytime you have a big stressor, like less nutrients in plants as opposed to milk, you need a little more grains. Too many grains reduce diversity, given the back slopping, and which is when a family gets really stable. And then too little grains, and you pretty much go into dormancy mode. It's a little stress, but usually that doesn't grow very quickly, and it could open up other environmental pathogens to take over. So this is the ideal amount. Let's keep going. And then kombucha, same thing, 55 grams organic cane sugar, 3.5 grams loose leaf black tea, which is boiled in water, so it's seeped. Usually there's 0 minutes in an Instant Pot. With natural release, 900 milliliters of RO water to 100 milliliters of starter fluid. This gives 1 liter. And This includes Kobe only after cooling or room temperature do you introduce it, and again the fermentation time, which for Kefir was that. For here it's 7 days at 70 degrees, is 1 day at 70 degrees. And again, you can adjust. If you have hotter, will be shorter, colder will be longer. Usually more starter fluid is shorter, more nutrients is shorter. Those are some of the less salt is shorter. So water Kefir this time, and you have 0.75 mason jar full of fruit to 15 grams, and there's always a 32 ounce, so 1 quart mason jar. It's close to a liter. 15 grams. Again, a cane sugar fruit. Vegetables, it's 30 grams if it's for vegetables, right? And then you have sugar, right? You're looking for 60 grams of sugar total, and then made it a little bigger just so everyone can see. Unsalted raisins, 2 pieces, or, is an or, blackstrap molasses, 1 gram, and that's your mineral. Dried fig, 1 day, and that's, again, some nutrients. And this typically does not exceed, if you go low on the added sugar and you have fruit like apples, it should hit around 60 to 70. You don't want to go over 70 for this one. 75 mason jar, RO water, reverse osmosis water, and then again, starter liquid including the water Kefir grains. It's usually, yeah, you want around a cup, and this would be around half a cup, so half a cup to a cup, including the water Kefir grains for a liter. You ferment at 3 days at 70 degrees, and then a second ferment at 1 day, same temperature. Do we want to take that? So here you have vinegar, which is very similar to water Kefir, except you do 30 days at 70 degrees, and liquid, you would remove or eat the fruit then, and then the liquid can be kept around for, the ACV in the pantry expires like in 5 years from date of purchase or manufacture. So if you remove it, this is what we were saying, in 2 days it's actually going to just be water Kefir, which is pretty cool. And yes, this can be done with pretty much any fruit and vegetable if you put sugars in them to compensate, which was covered. This is a saline lacto ferment is usually what's said. So 2.25% seems to be the sweet spot. 2.5% is left optimal, but okay. You want it around 2 to 3%, but this seems to be optimal for, again, strain diversity and CFUs. That's going to be Celtic sea salt again, and then you want to put about 0.75 mason jar full of solids, so that's whatever you're doing, whether it's fruit, like apples or vegetables. Again, this is going to be salt driven. It's going to end up with different strains in your sugar driven ones. And then if you want to backslop, you can use 100 milliliters of starter liquid, which includes at least 1 backslop solid. And why solid? It's because solids have the beautiful buffer that a lot of microbes require to maximize diversity from pH, from salt, and it introduces diversity. If you just use brine, you're going to get less of that strain diversity. Here, this is Koji. So anytime you see greater than, this means this is preferred. So Shirayuri is very protease heavy, and it usually ends up with the best umami and the best not only success rate but also diversity. Where Shirajiku is a little less protease, so less protein breakdown, and Kawachi is very amylase, so very starch breakdown. again, typically for diversity, you want to have this one. This one's alright, and this one's really for fast ferments with a lot of Koji ratio and lower salt. 1 kilogram white rice. You have soaked in oil water for greater than 1 hour. Then you cloth wrap it and pressure steam it. Yes, with the cloth wrap. Takes up to like, I think 300 Fahrenheit to start burning. Like, if you can even use that for like degrading cloth, and it doesn't get that high. It doesn't go up to 242 Fahrenheit in an Instant Pot duo. And then you pressure steam it for less than 4 minutes. That's what for rice. And then you inoculate it right when it goes past 90 degrees, so 89.5 degrees. You inoculate this white rice with the Koji spores. And again, just 1 gram per 1 kilogram. And then you incubate with wet cotton at 87.5 degrees. You can use a heat map, a heat pad, mat. You can use, some people use an oven or an incubator, and then you're going to do that for 48 hours, and you should turn into not Koji spores, but the step before that, a finished Koji. So that's that. 4% total weight Celtic salt. So this is for miso. This can range, and I think we put this, yeah. We'll cover it now. This can range anywhere from 2% to, I've seen it go 20% or more. Lower, riskier, more diversity, faster. Higher, less risky, more traditional, much longer. Okay, so 4% seems to be the sweet spot. There's a guy on YouTube who does 4%. Works out great. He does typically fast 3-month ferments. So 4% total weight is Celtic sea salt. 4% total weight is Koji. There's 1-to-1 Koji water because you want the Koji soft. And again, you want it right before drip when squeezed, so you don't want water drops coming out of it when squeezed. And then 56%, which is the remaining of the total weight, you want it to be one of these that are soaked overnight and steamed. We can do and steamed in this. So soaked overnight and pressure steamed at normal pressure cook time. And what this means is you want to take, so anytime something says, well, pressure cook it for, let's say, 10 minutes, they typically mean pressure boil underwater. So for lentils, a lot of them are around the 9, 10, 12 minute mark. When you pressure steam it, usually the trick is you soak it overnight for 8 to 12 hours, and then you pressure, so fill it with 2 cups of water, put some sort of like flour tray or some sort of thing to hold it above the water, and then like a heat rack, and then steam rack, you cook it for that exact time. So it's steam for 10 minutes, but now that it's softened, it just works out. It works out beautiful. So, and usually I get the times from highpressurecooking.com. I used to, now I just looked, and there's a lot of AI stuff just gives you the time, so you can use that. At least 2 tablespoons Celtic salt saved and spread on top. That's to not have microbes coming in. And with anaerobic water is the moat lid, glass weight, ceramic weight. I think we talked about that in the setup earlier in this video. And then it's 1 to 3 months at 70 degrees. And we talked about the note here. Whereas usually if it's lower, you're going to want it faster. So 1 to 3 months. Longer. You can see here 8% is usually and you're looking for red meat, so it's going to be 9 to 12 months. So that's that. In sourdough, we have starter finished, and this references the water plant, the water kefir. So you're going to take 100 milliliters of that, and you're going to take finished salt brine, so the salt ferment, 2 tablespoons of the starter liquid in there, and you can add a solid. Can you? can. And then, again, that's just to preserve the microbes diversity. And the reason you do both is this is going to give you one set of microbes, and this is going to give you a totally different set, especially the lactobacilli. And you really want both when doing a sourdough starter. You mix that with, so 1:1:3 is starter water sorghum flour. That's the ratio. And then it will start to grow. And that, at 70 degrees, let's see if we cover it. Okay, so here is when the starter is ready, and this is when 95% will be the final bread and 5% will remain for future batches. If you're wondering when to refeed the starter, let's say you don't have enough. So your initial starter culture is like this big, and you really want to double or quadruple that. You want to refeed it again, and the refeeding occurs at 70 degrees, usually 24 hours after you've done this. It should... It should be ready to be fed again. And how you know that is right when you feed it, it'll start expanding up. It'll dome, and then it'll start to flatten. That's where you want to feed it. Otherwise, it'll keep going down, down. You don't want that. That means acidification is taking place. If you feed it too much, so if this goes way too high, and sometimes it's a 1-2-2, 1-1-3 seems to be the best. But if that goes too high, you're going to give way to a lot of yeast. If it goes warmer, you're going to give way to a lot of yeast and some very LAB, so lactobacilli, that love high substrate. If you feed it too little, that could result in failure for a lot of reasons, like pathogens, or it also suppresses yeast. So do cold temperatures, most yeast. That usually just slows down the feeding and lengthens the feeding window almost. Except you also reintroduce bad pathogens and have a higher chance of failure if you feed too low. So this is a great ratio. We've added millet and teff flours. So if you use sorghum flour, millet, flour, and then teff flour, same ratio. If you want to kind of mix them, so you keep the 3 ratio for flours, but you could mix. You could do 1-1-1 to add up to 3, for instance, if you really want strain diversity. If not, sorghum flour is fine. And then after you're ready for the bread to go, so let's say you have a lot, like quadruple the size of where you started, 5% of that total weight is going to be in psyllium husk, 2% of the total weight is going to be Celtic sea salt. And then you're going to want to score that for 30 minutes at room temperature with a cloth cover, and then a plastic cover over that, and just wait at least 30 minutes. You can do an hour or two, 30 minutes. And then the second step, once you've done that, you want to okay, so you want to rest and proof it for 30 minutes is a technical one. Then you want to score it, and usually if you're scoring, you want a 45 degree, 8 millimeters deep, and at least 90% of the full bread to make it rise optimally in the oven, which you're going to bake for 450 degrees right after that for about 40 minutes. And the first 20 of those minutes are going to be anaerobically covered, like a Dutch oven. You can like put a pan on there. Some people put a bowl on top, and then you cool down exposed to 70 degree air until 70 degrees, room temperature, etc. And that usually takes about an hour or two. No fan or no fridge for the best consistency. Those are the major ferment categories, and I walk through them so to make optimal CFU and optimal strain diversity. Yeah.